Well, hello scrappers, Mike here. Welcome back to my channel. And it's time once again for another clean out of my silver cell. This is going to be the second clean out. I published an update not too long ago about what was going on with the cell. And I said at the end of the update, well, it was getting close for time for a clean out. And sure enough, it is time for a clean out. Look at all the silver in there. Oh my goodness. I will give you a close-up look at that harvest of silver in there with my phone, which does much better with close-up video, and show you just what we've got going on in there. There is an amazing amount of very pretty, very shiny silver crystals in there. All right, will you just look at this? Look at this. Look at the silver. Oh my goodness. Long blade-like crystals in there? Holy cow. Yeah, I think it's definitely time for a clean out. Yeah, on this last run in the cell, I started out with very, very clean electrolyte. You know, sort of bootstrapping my way up from having dirty silver to start with to having clean silver. So, very clean electrolyte this time. Some of the silver that went through here went through for the second time. And I think we've probably got some really clean silver crystal down here this time around. Probably much cleaner than the first time. And it's also, I was running the cell at only half an amp, and I had it on my hot plate to warm the cell up because the electrolyte's much more conductive when it's warm. I was running it at 50C for most of the time, and at half an amp and fairly low voltage. And I think, you know, we've got chunkier crystals than the first time around. These seem much chunkier. And from my research, they should be purer crystals. Since I was running at much lower voltage, hopefully we were pulling less of the junk over out of the anode bottle. There should have been less voltage there to mobilize other metals. So, in theory, we should have some really pure crystal. Okay, I'm going to start doing a clean out on this. I'm not going to go into the same level of excruciating detail as I did in my first clean out video. I'll put a link to that in the upper right. You can check that out if you like. We're going to go through this fairly quickly. Get the anode bottle out, clean it out, dump the used electrolyte off of the silver crystals. We will harvest the silver crystals and clean them up and then dry them and weigh them. And we'll process the used electrolyte and deal with the anode slimes in the bottle. And then, you know, basically after I make some more electrolyte, the cell will be ready to restart. So let me glove up, none of my gloves on, and get started. All right, step one. Let's get this used anode bar out of here. There's not too much left of it. It's pretty eaten up. Get the anode slimes off of it. Oh yeah, with the slimes off, there's even less of it. Yeah, this silver bar is about 8 inches long when it first went in there. So, and that was not the only anode bar to go through this thing in this run of the cell. Get the stir rod out, which I used to knock the crystals down as they grew up towards the anode filter. Get the anode bottle out. Put it over here so that it can, well, it'll drain slowly, but I'll deal with it shortly. I'm just going to set it aside for now. And what I want to do is I want to pour off the used electrolyte off of the crystals in here. Oh my goodness, that's a lot of silver in there. This is a heavy bottle. Oh, some of those crystals, they look like swords in there. They're so long and sharp. You get the sword fight with somebody with them. Wow. Probably bringing over a little bit of silver, but that's not a problem. It's just going to be the really, really fine stuff. It'll settle to the bottom. I'm going to eventually recover the silver out of the electrolyte by cementing it out on copper. So any little bit of silver that comes over will just join that. I'm going to try and get any palladium that's in here out of here first, but we'll talk about that in a little bit. Let me rinse this stuff with some distilled water. See if I can shake it down off of the cathode bar a little bit. Yeah, I'll have to scrape this. Get a Bondo scraper out and scrape the cathode. See if I can find something to scrape that cathode off with. Okay. Scrape this down. Stuff off of it. For the most part, the crystals don't really stick to the cathode that strongly. The sharp edges, where I cut it out of sheet stainless steel, they do tend to stick a little better to that, but on the whole, they don't stick too bad. I'll put a link to the video where I built this cell in the upper right. If you're interested in building one like this, this is an Anthony Thomas style cell. I don't take any credit for the design. It's all his. I may run it a little different than he does, but it's his design. And in that video in the upper right, there will be a parts list for everything you need to build this cell. So maybe I'll repeat it down below in the comments section. Or in the description section. We'll see. Alright, I got the cathode good and cleaned off. I'm going to give this a couple more rinses in distilled water. Get the blue color off of it. Whoops. Yeah. I may fish that stuff back out. That's a lot of silver to lose there. I normally do this through a sieve, but I forgot to put my sieve in. So yeah, a couple more rinses, and then I will dry it out so we can weigh it. So there's all the silver crystals from the latest harvest. So shiny. Yeah, nice. Looks like we got a good amount of it here. They're still wet. I got them in this Corningware dish. I'm going to put them on a hot plate in a fume hood on low heat with the airflow going and dry them out. Then we'll weigh them up and see what we got this time. Okay, I am going to take this wooden disc off top of the anode bottle. Lots of great suggestions in the last couple of videos on how I should deal with the top of the anode bottle. I appreciate that. Thank you. I may implement some of them. See about getting the anode slimes out of the bottle here without spreading them all over the bench top. Yeah, there's a lot of solids in there. Even really shiny silver, when it goes in, looks good, but there's a lot of stuff in it that you don't want in your silver. So, based on the amount of crap I'm getting out of the silver here, that's another reason I think it's probably pretty pure this time around. Not all of the silver that's gone through is stuff that went through the first time. Probably about a 50-50 mix. Some of it was just more silver that had been recovered from cement silver, from relay contacts, and from whatnot. All right, there we go. That's pretty clean. I will change the Dacron filter before I restart the thing. I'm going to let this stuff settle a little bit before I try to deal with it, just so I'll be able to pour the clear liquid off the top of the slimes. So I don't plug my filters too badly when I filter this. All right, this stuff has clarified some. Let me hook up vacuum to it. And we will vacuum filter these slimes. Catch the slimes on the filter in here. And the clear liquid should go through. Oh, look at that. Isn't that appetizing, huh? Yeah. You let the liquid go through, and then I'll put these slimes in. The liquid that's coming through is much greener than the electrolyte that was on the silver. So the anode bottle retained a lot of nastiness. That's good. That's what it's supposed to do. All right, got the bulk of the liquid through. Actually, it looks like all of it. So in goes the slimes. Kind of chunky. So these slimes should contain everything that's not silver that was in the silver. So there's going to be copper here. Well, I would suspect the bulk of it's probably copper, especially from the green color. Fairly dark green. But I'll bet we've got some palladium here. Palladium's been an ongoing issue since most of this silver came from Johnny's relay contacts, which seem to have a lot of palladium in them. And there might be some other stuff too. Could be anything. Could be lead, tin, zinc, maybe even iron. Who knows? But at least it stayed in the anode bottle and didn't go through into the electrolyte for the most part. We started with some good clean electrolyte, and I stopped the cell before the electrolyte got too dark. So I think we're going to have some really good pure silver. All right, I want to let this pull through. I'll rinse the silver out of the filter in here. I'll give you a look at how much slime we got. All right, so here's the anode slimes. It looks like black nastiness, but really what it actually is, as far as I can tell, is very finely divided metal particles. All those metals I said could be in here as an impurity in the silver. Copper probably being the main one, palladium, iron, zinc, nickel, you name it. And those things did not want to participate in the electrolytic refining, just as the nature of how electrolytic refining works. So they stayed behind in the anode bottle. The silver went ahead through the filter and played it out on the cathode, and all this stuff stayed behind, which is good. That means we got much purer silver. But there's probably some valuable metals in here, so we're not going to throw this stuff out. I'm going to put it with Johnny's anode slimes for future processing. All right, so I've done the filtration. I've got the nasty anode slimes in the anode slime bottle for safekeeping until I have enough to bother processing. I'm going to add this liquid to this liquid. Now, notice the green color. This is somewhat green too, but this is very green. So I know we have copper contamination, which gives us a blue color, okay? But there must be something yellow in here too to make green, because green is blue plus yellow, you know? So we've got to have a little bit of contamination from something else in here. And I suspect, you know, based on my experience with this material, that something else is probably palladium. Maybe some other platinum group metals too, in very small, tiny quantities. Don't get your hopes up, Johnny, for a lot of platinum or rhodium or iridium. There could be traces, but I think what's making this greenish is palladium. So we're going to try and get the palladium out of this before I throw some copper in here to cement the silver out. So I don't want the palladium following the silver back into the silver cell. The silver I cement out of this liquid, I'll run back through the cell to purify it again. I'll melt it down into anode bars and run it back through the cell. We'll get it nice and pure. But I don't want to put palladium in there if I can avoid it. So I've got my spritzer bottle of DMG water here, dimethylgloxime. And we're going to put some of this in here and let it sit for a while. The undissolved DMG always plugs up the nozzle. There we go. I'm going to stir it up good, and look at the color right there. I don't know if that's showing up. Yeah, see that? Yeah, we got some palladium in there. This is going to form a bright yellow salt. The DMG water is with the palladium, and that's going to settle out over time. And we're starting to see it right there. Oh heck, I'm just going to dump some of this in since that undissolved DMG is plugging the nozzle. Gonna dump some in. I'm going to give it a good stir. Oh yeah. How much the color's changed. We've definitely got, I think, a fair amount of palladium in there. So we'll let this settle out. I'll probably add some more DMG to it later after it's had a chance to settle for a bit. But yeah, look at the color change. It's definitely going yellow, and that tells me that we've got palladium in there. Possibly, like I said, just a tiny smidge of other platinum group metals too, but mostly palladium. Anyway, this is forming. It's gone opaque, as well as changing color. This is forming an insoluble palladium complex that's eventually going to settle out to the bottom of the beaker. And I will filter that off, and then we will cement out the silver in this liquid with some copper. Okay, it's been about a half an hour, and as you can see, a lot of this stuff has settled to the bottom. We got a nice yellow layer down there. This is still quite green. Part of that could just be the yellow salt that's formed and has not yet settled out. But I'm going to put some more DMG water in it and give it a good stir again, and then let it settle again. And I'm going to keep doing that until all we've got left is a little bit of blue color in there and no more trace of yellow. So I want to get as much palladium out of here as I possibly can before cementing this silver in here out on copper. I just don't want to put it back in the silver cell. So we'll see what that looks like after it settles out again, and I'll give it longer to settle this time, maybe a few hours or the rest of the day, and then we'll see what the color looks like. Right, let's find out just how much silver we got in this harvest of the silver cell. Okay, so we're on 0, we're on the gram scale. I'm actually wondering if this beaker is going to be big enough to hold it all. I guess we will find out. There's some seriously shiny stuff. These are big chunky crystals too. The first batch had a lot of fine fleecy crystals. Look at that. An even bigger one down here. Look at that. Oh, that's so shiny too. Wow. Where are we here? 185 so far. 231. Looks like a pretty good batch. I don't know if this beaker is going to be big enough. 316. Maybe we'll make it fit. Uh-oh. A few bits went on the table. I will collect them, but I don't think they're enough to make much of a difference. 394 grams of very pure silver. Some of it landed on the scale, so that got counted. All right. Oops. Let's stick to my gloves. Well, I will clean that up. Now we're up to 395. Okay, so 395 grams of very pure silver. I'm pretty darn happy about that. Just short of 400 grams of pure silver. Wow, I am loving running the silver cell. And the next batch of electrolyte I make will be made with this stuff right here. Let's see, I will put this in a very clean container and set it aside until I am ready to make the next batch of electrolyte. All right, so this is Saturday. I actually added another shot of DMG water to it off camera and stirred it up again. But I think that last shot was probably unnecessary because it didn't clear up anymore. It still looks a little green, but I think that green is due to particles of this very yellow powder suspended in the blue liquid. I think that's why we're getting the green color. So this stuff is very fluffy. It looks like there's a lot of it here, but there's not really. It's very fluffy. It's very slow to settle, reluctant to settle. The liquid's dense because it has a lot of silver nitrate dissolved in it. So this stuff isn't settling out very good. So I'm going to have to filter it out. My original plan was to siphon it down a good bit and then filter the rest, but that's not going to work because there's just so many little particles of yellow stuff suspended in the liquid. So I'm going to have to filter all of it, all 5 liters of it. That's going to take a little while. You don't have to watch. I'll be back when I get this filtered and into another 5-liter beaker, and we'll see how much palladium salt we've got caught on the filter over here in the Buckner funnel, and then we'll move on from there. Hopefully the liquid, once I get it filtered in the other beaker, will be nice and blue. Should be. I put enough DMG water in there. Yeah, the filtration's going good. Taking a little while, but we're almost down to the end here. I'm sure this stuff will clog the filter once I get it in the funnel. So, but yeah, the liquid's coming through nice and blue. It's not green anymore. So we've got the palladium out. It's all here. So that's great. So when I cement the silver out of this stuff, I can melt it down and run it back through the silver cell. And I won't have to worry about putting palladium back in the silver cell. Excellent. Alrighty, so here's the palladium complex caught on the filter. There's a little bit more of it than I was expecting. A little bit more than just a yellow stain. So that's okay. We'll recover the palladium from this sometime in the future. It looks like we also got a little bit of fine silver in there from the bottom of the beaker. That's fine. We'll recover that too when we recover the palladium, because this filter is all going to be contaminated with silver anyway. There'll be silver nitrate in there. So at some point I'll have to separate the palladium and the silver, so I'm not too worried about a little excess silver in there. We'll get it back in the end. Alright, I'm going to get this filter in Johnny's palladium filter storage, and then the rest of this liquid all together, and we'll cement out the silver out of it. Okay, it is time to cement the silver out of this stuff. This is all the used electrolyte, the liquid from the anode bottle, the rinse water, everything. Got my GoPro going because you guys do seem to like the time lapses I make of things like this, so here we go. Now this liquid is very, very cold, so I don't know exactly how quickly this reaction is going to take place. It's been a very cold couple of days. I see silver developing on it. All right. Yeah. copper's all covered with silver already. Okay, well, we'll see what the time-lapse produces. GoPro's going, so I'll cut it in here. Well, I was just going to cut the time-lapse in here, but wow, that is just going like crazy, like gangbusters there. I don't know what the time-lapse is going to show if everything's moving it so fast in there. I'm sure as the bulk of the silver comes out of solution, things will slow down. But wow, we've got a serious cementation going on there. It's like a blizzard in there. So I'm going to let this go like I normally do, probably for at least 24 hours, if not longer. I mean, especially when it's cold like this. Wow, there's a big avalanche right there of silver. But especially when it's cold like this, I expect it's going to take a while to get every last bit of silver to come out of solution. So I will just let this go for, into tomorrow and maybe even the next day. Though my GoPro battery won't last that long. At some point, it will crap out. Well, would you look at that? This has been going on for maybe 3 hours now. Look at the amount of silver in there. Wow, that's just crazy. Absolutely crazy. See those shiny crystals on those pieces of pipe in there? They're really shiny too. Wow. All right, I'm about to call this. It's getting late in the day, so I will grab the GoPro here shortly, and we'll see what the time-lapse looks like. Well, it's the next morning, and holy moly, I can't really even see in there. Yeah, okay. That is a lot of silver. I know I made the electrolyte a little stronger this time than last time, but that is a lot of silver. Of course, it's fluffy. So, anyway, what I'm going to do is I'm going to filter this liquid off and capture all of this silver. And I'm going to rinse it with hot water multiple times. This should be pretty clean silver down here. We got the palladium and any other platinum group metals out of it with the DMG water. So the main contaminant in this should be copper nitrate right now, which I should be able to wash away almost 100% of that. But still, I'm going to melt this stuff down and make anode bars and run this all through the silver cell and make sure we get good pure silver out of it. So that's the destiny of this stuff. That was a really vigorous reaction. The question I have, is it done? Or do we still have silver in solution? Because I don't want to filter this liquid off the silver until I know I've got all of the silver out of it. Yeah, are we done? I don't know. So what I want to do here is test the liquid to see if there's still silver in solution. I've got a little bit of tap water here with a bit of muriatic acid in it. And what I'm going to do is grab some of this. Of course, I've cleverly disturbed it now. So it's a little bit turbid with fine silver, but oh, that's still very clear. There's no silver in solution. Just a little bit of turbidity that I stirred up. All right. I'm a little bit surprised, as cold as it's been, that went to completion so quickly. But okay, I'll take it. All right, so I will get set up to filter this stuff and capture all of the silver in here on a filter and start cleaning it up. All right, here I go, filtering the liquid off of the silver. This is going to take a while. There's a lot of liquid here, and the floating silver is already plugging my filter, so it's slowing down. Eventually, I'll get through it all and get all the silver into the filter here, so I can start cleaning it up. It's going to take a while. You got to have patience if you're going to do what I do. Nothing's ever quick and easy. But for you it is, because you don't have to watch this whole process. I'll be back when I'm done and I've got the silver in the funnel up here. Well, there's all the silver in the funnel. I need to give it some hot water rinses and get as much of the copper nitrate out of it as I can. Here's the waste liquid over here so far. Now, this stuff's going to go into my waste processing system, and all the copper, which is giving the liquid its dark color here, is going to be cemented out on scrap iron and steel in my waste buckets. And I will recover that copper at some point in the future. In fact, I recently put out a video on doing just that. I'll put a link to that video in the upper right. You can check that out if recovering copper from your waste liquids interest you. All right, let me get some hot water and start giving this some hot water rinses. Okay, I'm rinsing the silver in the funnel there with some hot water, and I'm going to keep doing that until the liquid stops coming through blue, and then for a while longer, just to make sure we get as much of the copper nitrate out of the silver as possible. It'll be clean as I can possibly make it before I make anode bars out of it for the silver cell. Then, if I'm using very clean silver to make the electrolyte, and silver as clean as I can make it, for the anode bars, the silver we produce in the cell should be as pure as I can make it. So that's what I want to do. It already looks like it's coming through clear, but I'm going to rinse it a little bit more. All right, I'm calling this silver as clean as I can make it. The water's been coming through clear for quite a while now. We've diluted the blue stuff down by a lot, so a lot lighter than that stuff. So I'm calling this stuff clean. Let me turn the pump off for a second and talk to you about something else. Now, the waste liquid over here not only contains copper, like I said, I'm going to run it through my waste system and get the copper back, but there's also a lot of copper nitrate in this stuff. And that copper nitrate was produced by dissolving a lot of silver in nitric acid and then displacing it out of solution with copper. When the copper went in, it became copper nitrate. So we've still got nitrate in here. Now you can get your nitric acid back out of this stuff if you got some time on your hands and you're looking to save some money. You can get your nitric acid back out of it. It's a bit of an involved process, but it can be done. Anthony Thomas has videos on his site about how to do it, but in a nutshell, what you do is you add enough sulfuric acid to this stuff to make copper sulfate and displace the nitrate ion and make it back into nitric acid in solution. And then you distill this stuff off and you'll get dilute nitric acid. You can redistill it up to the azeotrope. Okay? So you can get your nitric acid back out of this. Right now I'm not too worried about that. I have a lot of nitric acid on hand, and I have a supplier where I can get it fairly inexpensively. I'll put a link to a video where I talk about that up here in the upper right. And right now my time is more valuable than trying to recover the nitric acid from this stuff. But if you guys want to recover your nitric acid, I just wanted to let you know you can. And I almost forgot to mention, if you are really thrifty and have a lot of time on your hands, you can recover both the copper and the sulfuric acid from the copper sulfate solution left over after distilling off the nitric acid too. You can use electrolysis to recover the copper and leave behind sulfuric acid in solution, which you can then concentrate by boiling it down. So really, this can be a completely lossless process if you want to take it that far. It's just a matter of how much time and effort you're willing to put into it. Okay, I'm going to get this stuff, I'm going to plug the pump back in and run it a little while longer and get this stuff as dry as I can. Then I will scrape it out of here, put it in a Corningware dish, and dry it on a hot plate. All right, all that cement silver has dried out. Nice dry powder here. So let's get it weighed. See how much we recovered from that liquid. We are on the grams. Yeah, this is kind of uneven. Let me find my bench top's a little beat up. There we go. That's a little bit of a more even space. All right. So anyway, let's see how much silver we recovered from the electrolyte, the anode bottle, whatnot here. Rinsing the anode slimes. Where are we? 232 grams so far. There should be, I would think, around 400 grams here. That's about how much I put into the electrolyte. Well, there might be more. How it got so concentrated, I am not sure, but there might be more. Nah, I guess maybe we're close to, I think it was about 450 grams I used. 450, 475 was my estimate. I just used a lot of 489. I may have been a little off on my estimate of how much silver I dissolved to make that load of electrolyte. All right, because I just grabbed whatever scrap silver I had laying around, dissolved it, purified it to make electrolyte. So we got 489 grams of pretty darn clean, I think, cement silver here. But I'm going to melt this down and make anode bars out of it and run them through the silver cell again so we get a really, really, really pure silver out of it. There's probably still, I would imagine, a little bit of stuff in there that I haven't got out. Certainly probably a little bit of copper. There might be some lead in there and a few other things that have followed the silver through the process up till now. Maybe even still a little bit of palladium. I might not have got it all out. Okay, so that's that. Let me get this crystal silver out, and we'll talk about where we go from here. Okay, so we got our cement silver recovered from the used electrolyte. Got the crystal silver, which should be very, very pure, recovered from the silver cell. I got a couple of used anode bars here that are just down to nubs, and I got an unused anode bar that I know is still pretty dirty silver. So I need to run this stuff through the silver cell. I need to run this stuff through the silver cell. So next run of the silver cell, that's what I'm going to do. Now, I'm going to be out of town for a while, so I'm not going to restart the silver cell in this video. But as soon as I get back, which will be about the time this video airs, I should be back, I'll start working on restarting the silver cell. Here's the question I want to ask you folks out in the audience. Do you want to see a video of me making fresh electrolyte out of this stuff, pouring some new anode bars out of this stuff, and getting the silver cell up and running? Just leave a comment down below the video, yes, no, or no, I'm tired of seeing silver cell videos. So, you know, I don't want to be too repetitive. So let me know what you think. Because when I get back, I'll tally up the votes, and I got to restart the silver cell anyway, but you know, if you want me to film it and make videos of it, I will. So let me know. So I'll melt this stuff, these down, and then we'll have some more bars to run through the silver cell with some really, really fresh, clean electrolyte from this stuff. So, all right, well, I hope you guys found this video interesting, educational, informative, inspirational, whatever. If so, give it a like, give it a thumbs up, and subscribe to see my future videos, including possibly more silver cell videos if you guys are interested, or not if you're tired of them. Let me know, and I'll see you in the next video. Thanks a lot for watching this one. Bye.